Yeah, good morning, everyone.
Morning.
Today we will be going through the benefits of short-term mine optimization, how it will benefit in short term. So, just few weeks back, I was in a mine and discussing with the mine manager about the challenges he is facing in improving the productivity and efficiency of the mine. So we were in discussion, then suddenly a phone call came to his mobile phone, and after some time on the call, I seemed that he is distressed. So he is a good friend of mine. So after the call, I asked him, why are you so upset? So then he told me that the QC department is revising the pile quality targets from the next one due to some changes in the plan. So I have to replan everything accordingly. So like him, I believe many mine managers and geologists must be facing this challenge, this new type of challenge more often than before in this dynamic environment. So why we require short-term optimization? The first question which comes in everybody's mind that we have already carried out detailed exploration, we have already estimated the resources, reserves, everything. Mining plan is also in place and operation is also going on. Then why I need short-term mine optimization? But due to various factors which has been listed here, this is, I think, a need of the hour. The change in the demand of ROM quality of limestone may be due to the plant side, or maybe it can be from the mine side. Like many companies globally are manufacturing different types of cement, like OPC, PPC, PSC, SRC, or OWC. So for OPC, PPC, and PSC, there is no requirement of changing the ROM requirement because the same clinker can be used for producing the cement. But some companies run OPC, PPC, or PSC for 9 months, and 3 months they are producing SRC or OWC, which has a different clinker characteristics, and accordingly the raw material requirement also changes. So this calls for short-term observation for 3 months or 2 months to produce the different type of clinker and cement. So the frequency may be once or twice in a year, but there is a demand. Now, as we all know that the fuel prices are very volatile nowadays, and many plants are pushing to use the alternate fuels in their kiln. So, with the change of quality of the fuel, the quality of raw material also changes. The impact may be, you can say, 1 month or 2 months because cement plants are taking the stock or importing for a ship that may last for 1 month or 2 months like that. So, every 1 or 2 months, you need to change minutely the quality of the ROM limestone to match the raw mix parameters. Limestone is also blended with several characteristics like clay, shale, sand, laterite, bauxite, etc. in the raw mix to produce the clinker. So if there is any change in the quality or source of the correctives, then again a raw mix design has to be run to suit the requirement of the plant and may change the quality of ROM limestone also. So depending upon the geology and quality control procedures that has been adopted in that quarry from where the correctives are being procured. So this may change in low frequency, may be low, medium, or high. So accordingly, you have to adjust your limestone quality also. Few cement plants are also procuring high-grade limestone to consume their marginal grade or low-grade limestone. So if there is any change in the quality of high-grade limestone for some period, because it has been procured in stocks, so if there is any stock is lying in the cement plant, then there is a need to consume that stock. So accordingly, you may have to adjust your ROM quality also to suit that requirement. Some of the changes may be from the mining side, like unforeseen issues in the mining. You have carried out drilling at 200-meter interval, and while mining, you find some another rock in between, or you find some more intercalations. So that material which was useful has now become waste or may need blending from the high-grade limestone. So such type of issues may also require to rethink about your planning. Another issue is availability of equipment. So, suppose you have planned 3 shovels at different locations to meet your pile quality requirements. And if one shovel is breakdown and you find that it is breakdown for at least 2 days, then accordingly you have to adjust your planning so that you can shift your standby machines to that place, or you can plan at new place because you cannot stop the production. Some changes in the statute may also require you to rethink about your planning. Like if some inspection has been carried out by some statutory body and he has put some restrictions that this area is unsafe for working and you cannot use it until and unless you make it feasible for again mining and as per the law. Or recently some NJT orders has been uh, come regarding the stone mining, in which the mines which are doing blasting, they have been prohibited mining in 200-meter zone from the villages, national highways, state highways, and other public structures. So this may come in the large open cast mines also. So this may also require you to rethink about your planning in short term. So long-term mine plans are okay. They have their own use, but cannot dynamically or speedily respond to the issues which are mentioned above. So this is basically the short-term mine optimization system. The exploration is being carried out and the data is collected by the client, and through internet it is being sent to the remote expert. The remote expert can prepare the block models, he can do the global optimization, he can do the long-term scheduling, he can do the short-term scheduling, and again send it back to the site. In this regard, for short-term mine planning, the blast hole sampling is very essential. So based upon the short-term and long-term planning, the remote expert will tell the sequencing of the blasting according to the needs and the mine layout, and is again sent to the site. So everything in this system is through can be carried out through remote, sitting in one office and responding quickly to the needs of the client. So what does this short-term mine planning use? Basically, it uses the real-time data and advanced analytics to make informed decisions whether we have to do it or not. The scheduling is carried out for optimized extraction, for steady supply of the homogenized material, because that is very important. The variations in the material may cause some fluctuations in the operation also. This quickly adapts to the changes in the quality requirement without affecting the production, because you have alternate schedules. The benefit of it is that regular and continuous updation of the deposit inventory on the short-term basis. And there is, of course, savings in the cost because we are using optimized layout and visit of the experts are avoided. So what is the methodology to be adopted to carry out this short-term mine optimization? So most of the participants here will be using the softwares like Datamine or Surpac or any other geological modeling software to estimate the resources and reserves, and are aware of the methodology. It is simply collecting of the data, preparing the drill hole database, then geological modeling, then after compositing and statistical and geostatistical analysis, you can create a block model. From block model, you can get your resources, and after putting up your ultimate pit parameters, you can get your reserves and all these things. So we are talking about the last two steps, what is mine optimization and what is mine scheduling. Since the limestone shall be used for the cement manufacturing, so the LSF, SR, and A are the major operating parameters for the raw mix. Thus, based on the raw mix parameters, we will carry out optimization and detailed sensitivity analysis. So in sensitivity analysis, we carry out various scenarios, and the most optimal scenario is selected for query global optimization. And based upon the query global optimization, we carry out query scheduling, which can be 5-yearly planning, yearly planning, or monthly planning. So this is the main thing of short-term mine planning. So you have got deposit model, you have put in your raw mix parameters and carried out global optimization and long-term planning. Based upon the long-term planning, you put your mine constraints and again the raw mix parameters to prepare quarterly planning. Now, quarterly planning is good for deposits which are simple and have not much variations in that. So from quarterly planning, again the raw mix or ROM parameters which are desired by the plant, and a monthly planning is made, because monthly planning is very easy to monitor and execute. In the monthly planning, the blast hole sequencing and scheduling is being done and sent to the client, and blast hole inputs are received, they are being geocoded, and a blast model is prepared. So from blast model, we can prepare the weekly planning, and with the pile parameters, it is very easy to monitor the weekly planning. In weekly planning, we also give alternate schedules so that the mine manager or mining engineer have clear idea. If this is not going to work, then this will work. So based upon the blast hole inputs and variations between the predicted and actual quality and feedback, we can revise the block model also. These are the tools available with us. Surpack, Datamine, we have geostats. For optimization, we have query scheduling optimization and Athos Geo. Other software like Mindtrace is used for carrying out grade tonnage study. Geostats is used for preparation of slice plans. And Mindset is also used for scheduling. Now we will take up a case study. This deposit belongs to a cement plant located in North Africa. As you can see from the section, the rock types are encoded in the area are marl on the top, then there is a layer of gypsum in between. Then we have limestone, two types. The top one is marginal limestone and bottom one dark blue color is high-grade limestone. You can see the crusher is distantly located from the plant and it is connected by a long distance uphill conveyor, which is about 7.5 kilometers long. So after deposit evaluation, you can see that the mine has 81.9 million tons of resource of marl and 108 million tons of limestone. So marl is overlying the limestone and is very highly heterogeneous and low grade in nature. Limestone is also heterogeneous marginal grade, which is overlying the 30-meter thick bottom grade limestone. Now the challenge here is to use marl and the marly heterogeneous marginal grade limestone, possibly to achieve the stripping ratio, lower longevity of the deposit life, and of course, low cost of production. Because if you will take marl and throw it in the dumps, then you can very well imagine that what will be the its stripping ratio. Now, the global optimization is carried out. For this, we have customized software QSO as well as Athos Geo. So in global optimization, the marl, marginal grade limestone and limestone both are considered as usable, and its impact of Aromics LSF on reserves has been studied under various parameters. So from the output, sample output, you can see that with the increase of LSF, the reserves are going down and the OB ratio is increasing. So similarly, for other parameters like SR, AR has also been studied, and the SO3 was also problematic in this deposit because gypsum was associated with it. So the SO3 content in limestone was also bit high. So in this, we have used the inputs of block model, ROMIX and ROM parameter of the limestone and cost data also to balance the lead from where we can get optimized reserves. So the outcome of this is that we have 89 million tons of reserves originally of limestone, which has increased to 137 million ton with LSF of 98. So the gain of total 48 million ton marl can be blended and used with the limestone. Overburden ratio has been reduced. During the study, it has been found that the silica ratio has a positive impact on reserves, that is reserves enhanced with the increase of silica ratio up to a value of 2.5. Increasing the alumina ratio up to 1.5 and maintaining the desired limit of SO3 of 0.9 in the ROMIX also resulted in enhancement of reserves. So you can see from the chart here, the reserves have increased 48 million tons and the life of the plant has increased 16 years. The recovery ratio or the stripping ratio has reduced from 1.02 to 0.545 and the cost of production has been reduced from 2.7 million per ton to 2 USD per ton of limestone. So by optimization, a saving of approximately 2.1 million USD has been achieved just by the reduction of the rejection or stripping ratio. The additional life will further add savings for additional 16 years of life, which has been gained by optimization. Now the long-term scheduling is carried out for the deposit for optimal utilization of the marginal grade limestone and high-grade limestone, maintaining overburden ratio within a block period of 5 years and optimum lead from mine phase to the crusher. During the 5-year plan, we have suggested to work in 2 pits to optimize quality parameters and take advantage of the profile to expose the high-grade limestone. You can see because the high-grade limestone is on the lower side and is exposed on the valleys. From the 5-year plan, the yearly plan has been made. So the schedule prepared has led to the flexibility in their mining and lead balancing and minimize the shifting of the equipments. Now we have carried out short-term planning. Because of the heterogeneity in the 2 blocks, you can see western block on the left side of the screen and eastern block on the right side of the screen. So 2 blocks were made ready for the production. Initially, they were using only the eastern blocks, and the mining is basically towards the bottom of the site to expose the high-grade limestone and consume it. So for short-term planning, blast hole sampling with their geocoding is being done, and the results were regularly sent to the Holtec. So from the quality, you can see both the blocks has very high standard deviation, showing heterogeneity. Eastern blocks, you can say, is close to the 7-grade limestone, but the western block would require blending with the high-grade limestone. So for short-term planning, the weekly blast hole planning is being made and sent, and sequencing is being made. Lead balancing has also been carried out, and small micro mining constraints has been considered in this short-term scheduling. Based on the blast hole data results, a blast model is prepared. You can see on the right side of the screen, this is the output from the QSO. So you can see the red color blocks, which has been selected at different places in the mine for exploitation with alternate schedule also. And based upon the scheduling, equipment allocation planning has also been done. The planning which has been made is also sent in the Google imagery to visualize which blocks we are going to mine, which is reject. So like this type of planning we provide. So you can easily visualize which blocks and which bench you are going to mine. This is one more case in which you can see the short-term scheduling has been carried out. You can see 3 zones with different colors. The red color is the reject and the green color is the limestone. So zone-wise mineral distribution can be seen on the right side of the screen. What is the distribution of limestone and reject in each block, and how much pile proportion we have to maintain to descend to the pile. Like from zone 2, it is 18%, zone 3 is 45%, zone 4 is 37%. So in the below figure, you can see zone 2 has a LSF of something 208, zone 3 is having 202, and zone 4 is having 225. So the pile requirement is around 200 and something. So pile has been made, and when the correctives will be added, and what will be the quality of the raw mix. So this addresses the weekly your pile quality maintenance. So blast hole is the main data which has been considered. So this type of reports we provide, like where is the location of the blast, where is the blast number, on which bench, what type of material it is, how much is the quantity, what is the quality, whether it will be fed to the pile or it will be kept as a standby. In the below table, you can see the allocation of the machines. In April first week, one shovel will be at B1SE blast and dumper number 1, 2, 3. Like this type of schedule, we give. In the bottom chart, you can see different blocks. So each block, you can find what is the quality of that block along with all the radicals and tonnage. So all the blast hole data which has been gathered is validated with the actual data of the predicted data of the model with the actual data of the blast hole, and the variation is studied. So if the variation is too high while operation, then the block model is again validated based upon the blast hole data. So this is very important aspect, because variation is very high, then the block model you have to update regularly. So what are the benefits in terms of short-term and long-term for a mining engineer? So he has got all the outputs, so he can take quick and alternate solutions. He has got flexibility in operations because he has got alternate schedules, timely and detailed analysis. And in long term, it will lead to efficient operation management. For manager, he has got multiple scenarios to evaluate, and a dedicated manpower which has been assigned to plan each and everything has been eliminated. So in long term, you are using your deposit optimally. Your quarry layout is streamlined, and there is continuous updation of the inventory, and you have a better control over the deposit. For companies, since you are using optimally the deposit and continuous streamlining of the query has led to the savings in the operation cost. And of course, there is, if your query is optimized and the operation is smooth, then it will lead to enhanced in the equipment life in uptime, and the deposit life shall also increase. These are the benefits for a case study in plant in North Africa. So initially they were operating, deposit evolution was carried out by simple classical method, cross-sectional method. So Holtec has done it with mining software, and grid tonnage curve has been established. So establishment of the grid tonnage curve give you a fairly idea what is the potential of my deposit, at what cutoff, how much is the reserves, and how much is the reject. Then we carried out optimization and raw mix design. We have carried out sensitivity analysis. The reserves were optimized and marginal and low-grade limestone used. The optimization has also led to the minimization of the correctives. The deposit life has been enhanced by 16 years, and the stripping ratio has been reduced from 1:1 to 1:0.25. So detailed mining and plan and short-term and long-term planning has been carried out. So this has led to the improved resources utilization and enhance the decision making. In the short-term planning, the quarry monitoring is being carried out from the remote place like our HO office. So blast hole samples were evaluated. Weekly plans have been made. Blending has been ensured. The mud which was being dumped as the reject is now used, so they require less area. So there is impact in the environment also. So mud is very soft, so drilling and blasting has been eliminated, and it is being exploited by ripping. Block model was also validated based upon the data. So there was a steady supply of homogeneous limestone. The total savings they achieved is around 2.7 million per annum. Another case of a cement plant in South Africa. So deposit evolution is carried out, optimization is carried out, and high and low MgO limestone optimally blended by maintaining the desired LSF. Use of correctives has been minimized. The life of the deposit has enhanced by 5 years, and the stripping ratio has been reduced from 1:2 to 1:1.12. The mining, they have estimated the limit up to 860 meters, but by suggesting some more exploration, the mining limit has been increased up to 800 meters. So there is an increase of reserves and flexibility of mining. Again, short-term scheduling was carried out, and blending of high and low MgO containing limestone was done, and block model was also modified. There was saving of around 0.25 million USD per annum. This is a case study for a cement plant in India. The plant was using high-grade limestone. So after optimization and raw mix design, blending of high iron containing limestone with the low iron containing limestone was suggested, and use of correctives was minimized. So this has led to the enhancement of deposit life by another 5 years, and the stripping ratio has been reduced from 1:0.33 to 1:0.11. The mining limit was fixed at 26 meter MSL. So after detailed mine design and further exploration, the mine limit was increased to -12 meter MSL. There was enhancement of 30 million tons of reserves. The plant was only using high-grade limestone, maintaining silica ratio at 2.1 and AR at 1.2. High sulfur limestone was also being rejected, and the stripping ratio was also high. So after optimization and short-term planning, the blending of high iron containing limestone with low containing limestone is effected. We also recommended and implemented the change SR and AR in the deposit. Stripping ratio was reduced from 1:0.33 to 1:1.11. High sulfur limestone is optimally blended and used with low sulfur limestone. Block model was validated. So a saving of approximately 0.24 million per annum has been achieved by this short-term mine planning. So thus it can be concluded that due to its dynamic and structured approach, short-term optimized planning has several benefits in terms of long-term for geologists, mining engineers, mine manager, as well as management also. Many of you must be knowing the Holtec. And before we proceed to the question and answer session, I would like to brief you about various other raw material services we have in our basket. So we cater to the industry, for various raw material services from project formulation to performance enhancement, which includes recurrence survey, geological investigation, computer-aided deposit evaluation and quarry scheduling optimization, mine planning, economical feasible studies, and other services. We have a vast global experience in providing raw material services in more than 35 countries, and till date, we have carried out more than 750 assignments. In view of this, we have extensive geological database and hands-on exposure to the mining operations in diverse and challenging conditions. Apart from various softwares, we also have customized mine optimization software, QSO, and AthosGeo.